Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about the average atomic mass. So what is an average atomic mass? When we talk about the atomic mass, we're talking about either the mass of an atom, a single atom, or the mass of a single molecule or formula unit if we're talking about ionic substances. And so here we're talking about the average atomic mass. And if we go back to our discussion regarding isotopes, the reason that we are talking about an average atomic mass is because each element has a certain number of naturally occurring isotopes. Now, not every element has isotopes, but most elements on the periodic table are going to have a number of naturally occurring isotopes. And as we learned from the video on isotopes, isotopes are elements of this atoms of the same element, but they differ in mass. So if we're going to talk about the mass of an element, say carbon, then we need to talk about an average, because we need to take in consideration the fact that we have different carbon atoms have different masses, right? And so that average is going to take into account all of those naturally occurring isotopes. And the reason that it's weighted is because we don't have equal amounts of our isotopes. So we tend to have one isotope tends to be more abundant or more prevalent in nature than other isotopes. So we have to take that into consideration as well. And so I use an analogy to help you understand why it's weighted. So if you look at quiz scores, and let's say that we have 10 quizzes. So you take the quiz 10 times, or you take different quizzes, but you got 10 scores total. So here you'll see that I have 8 quizzes where I scored a 10 out of a 10. So I got a perfect score. So all of these tests or all these quizzes are out of 10. So on one I get a 10 out of a 10. And then on 2 of them I get a 9 apiece. So 2 of them is a 9 and 8 of them are 10s. So if I was to find the weighted average of this is what I would do. Now, the way I'm going to be doing it is not like the way we would normally do it if I wanted to find the average, my quiz average. Because I would just add all these numbers up and divide by the total number of quizzes, right? So I would add all these numbers up and divide by the total number. But I'm going to do it differently just so that you could see the weighted part of it, right? And this is going to help us understand why we're going to be doing it when we get to the isotopes. Okay, so I have my quizzes. And so what I'll do first is I get the total number of points that I got from each quiz. And the way I do that is I multiply the number of the quizzes that I got by the point value for each quiz. And since they're all the same, it would just be 8. Since I got 8 quizzes total, each one is 10 points. So I multiply 8 by 10 and I get 80 points. So then I do the same thing for this group here. So here I have 2 quizzes, 9 points each. So I add those together. So 2 times 9 is 18. So I took the number of quizzes with that score and I multiplied them together to get the total number of points from those quizzes. And I did that for this group and for this group. And then when I got the total number of points from this group and this group, I add them together and I get 98 points total. Now, to get the average, since I have a total of 10 quizzes, each quiz was a maximum of 10 points, so that's a total of 100 points. So I divide by 100 and I get 9.8 for my total score. So what you can see here is this is a weighted average, mainly because you can see that 9.8 is closer to 10 because I have more quizzes with 10s than I do with 9s, right? So it's expected that when I find the average, it's going to be weighted towards the quiz that I have more of, the quiz score that I have more of. Since I have more 10s than 9s, my average is going to be weighted more towards the 10 than the 9. So I hope that is clear, right? So how does this translate into the isotopes and finding the atomic mass, the weighted atomic mass? Well, if we have our two isotopes here, I have boron 10 and boron 11. And for each of these, I have the percent abundance in nature of both of these. So this boron 10 is 19.9% of all boron atoms are going to be a mass number of 10. And then 80.1% of all the boron atoms in nature are going to be boron 11. So this is our percent abundance. This is the number that I have per 100. So for every 100 atoms of boron, 80.1 of them is going to be boron 11, and 19.9 is going to be boron 10. And so, oops, excuse me. And so over here you also have each boron, boron 10 and boron 11 has a certain mass. And I just round it to 10 to make the numbers easier. So the mass of boron 10 atom is going to be about like 10 AMUs. AMU is a mass unit, atomic mass units. So we have 10 AMUs for boron 10, 11 AMUs for boron 11. So I have the masses of each isotope of boron, and I have the percent abundance, how much per 100 that I have in nature. So what I can do is, if I can treat the percentages here kind of like the number of quizzes that I have of each kind. So this is the amount of isotopes I have that have 10, a mass of 10, and this is the number of isotopes I have per 100 that have 11. So it's kind of like my quizzes that I have 8 quizzes of 10, I have 2 quizzes of 9. Here I have 19.9% of this boron that has 10 and 80.1% of the boron that has 11. So what I'm going to do is, to find the weighted average, I do the same thing I did with the quizzes. I take the amount that I have and I multiply it by the mass. In the same way that I take the number of quizzes I have and I multiply by the points that each quiz has. So the mass times the amount, and I treat this as out of 100. So out of 100 atoms, 19.9 of those atoms is going to have a mass of 10 AMUs. So I'm going to get the total mass of these atoms here. Just like I got the total points of my quizzes here. So 8 times 10 gives me 80 points total. So 19.9 times 10 AMUs gives me a total number of AMUs for these atoms here that have that mass. And then I do the same thing for this. So just like I did 2 times 9 points gives me 18 points total for that group. So 18.1 out of 100, so 80.1 atoms multiplied by 11 AMUs, because each atom has 11 AMUs. Multiply that, and I will get the total amount of mass for this group of atoms. So I get the total number of AMUs for this group here, and I get the total number of AMUs for this group here. And then just like I added them together to get the total points, I add the 2 groups together to get the total mass of atoms, and this is out of 100 atoms because I'm assuming 100 atoms because of the percentage. So this gives me the total mass. Now, this has to be the average mass, right? So I take the total number of AMUs, the total mass that I got for my two groups, and now I need to divide that by the total number of atoms. And so because of my percentages were out of 100, so I divide by 100, and then that gives me 10.8 MUs. And so this is the weighted average of boron, taking into consideration the percent abundance and the masses of each one. So you can actually break this down into a fraction, right? So here I'm dividing by 100. So if I take these two, it would be like I'm taking 19.9% dividing by 100. So if I take 19.9 divided by 100, that gives me the fractional abundance, right? Because it's a fraction out of 100. So, and then I multiply that by 10 to get the mass due to that fractional amount. And then I'm adding that to, again, I have 80 divided by 100, so I'm taking the percentage divided by 100 and getting the fractional amount, and then multiplying that by the mass, and I get the same number. So basically, in effect, to find the average atomic mass, I find the fractional abundance, which is the percentage divided by 100, multiplied by the mass of that isotope, in this case 10. So whatever isotope I have, I find the fractional abundance by taking the percent abundance and dividing by 100, unless they give you the fractional abundance already, and then multiply that by the mass of that isotope. And then I'm going to add it again to the other isotope. So the second isotope, I take the fractional abundance, the percentage divided by 100, and I multiply that by its mass, and I add them together. And then if I have 3 isotopes, I would do that with the third one. If I have 4 isotopes, I would do it with the fourth one and add all of them together. And my result is going to be the average atomic mass. And that average atomic mass should be very close to the average atomic mass that I find on the periodic table. And so just really quickly, as far as the average atomic mass on the periodic table, if you remember this symbol on the periodic table, here is the symbol of carbon. Remember the number on top is a 6. That's your atomic number, which tells you the number of protons, 6. But on the bottom, you'll find another number that is usually expressed as a decimal. So for carbon, it's 12.011. This is the average atomic mass of carbon. So you'll see that it's weighted very close to 12. So that means that because the average is very, very close to 12, that should tell you that the abundance, the most abundant isotope of carbon is carbon-12 because it's weighted towards that particular isotope. In the same way, you can see that this isotope, the average, weighted average for boron is 10 to the 8, and 10 to the 8 is closer to 11. So you can see that boron 11 is closer to boron 11 because you have a lot more boron 11s. So that makes sense. So the weighted average is going to be closer to the number or the weight of the isotope that you have more of. So just like this one, just like our test score was closer to the one that I have more of, the test that I have more of, then the same thing with the isotopes. The weighted average is going to be closer to the isotope that I have more of. Okay, I hope that was clear and insightful. I hope you got a lot from it. If you like this channel, subscribe to the channel, share this video with your friends. Click the notification bell if you want to receive notifications for more videos. Make a comment in the comment section. So if you have anything you want me to go over, I can go over that in another video. Thank you for joining me, and I'll see you next time.